Assalamualaikum. My name is Moeed Ahmed, and today I'll be explaining to you about change detection analysis using ENVI. So let's start. So first we'll open ENVI. Okay. Now we'll go to basic tools, and there we will select change detection, go into the change detection, and there we will go to firstly compute difference map. So let's open new file. I have already downloaded file of Landsat images. Show you. I've downloaded classification file of a Landsat image of a hurricane. This is a pre-hurricane Katrina. The hurricane name was Katrina. It was pre-Katrina file before hurricane hit, and this is a post-Katrina hurricane file, which shows the images of after the uh, hurricane was hit. These are before and after. This was of 2005, the pre-Katrina hurricane which was hit, and this was after the hurricane hit in after effects in 2006. So firstly we'll open the pre-Katrina file. We'll open it like this one. Press OK. And now we'll select the final state image. It was after the hurricane, post Katrina file. Select this one. Press OK. And it's saying we should save the output. We'll save the output here and create a new folder. We will save our output. Detection. Once computing the difference map after, before and after, and we will see the changes. First we'll load the before profile. This is basically the area selected, classified with the hurricane hit before the hurricane hit. This is the area of our interest, and then I load the after in a new display. Sorry, load band to new display. This is post Katrina. Okay, you can see the changes, but this is very minor changes. Now we'll finally display our change detection map changes, which will, so you can basically get more clarity. As you can see, these are the changes. These are changes that are made after the hurricane hit. You can see the change detection between the two images of this way This is basically a change detection map for computing difference between changes between the pre image of the land and this and after the land, after the hurricane was hit, the changes after it happened on the land. You can see. So now we will compute, as you have seen the changes of the map. We have displayed the data. Now we will show the statistics. We will compute the statistics table. So next step is computing the statistics table. We will go to basic tools, change detection. Now we'll go to change detection statistics. Okay. We have already output. Sorry, this is we have to select the initial state firstly. Okay, and we have to select the final state. This is post Katrina data. Now we have all the paired classes here already, so I don't have to add any classes. Okay, all the classes will be exported into the output. Report type pixels percent area. All have set. And now we'll output our change detection table statistics. Output change detection statistics. Okay. It is computing our change detection statistics. Statistics basically the changes which were happened after the hurricane, the changes on the land, the water, and other data. We'll compare statistics. Now, as you can see, this is basically the class total of the initial state, the pixels, total pixel of the initial state. This one. This is basically the initial state, the pixels of the class total. And the row total is basically of the final state, the pixels of the final state uh, of each class. For example, of mixed forest, this is the class total of the is 790. Of what bare land, the pixels total pixels are 31,329, and the total pixels of the water are 15 million, 15 lakh, and this is basically the class total pixels of each of the attribute, right? So now we'll see the effect. As we can see on the statistics, in the statistics table, we can see the image difference. We'll see that uh, it is in negative. So we can see that it has lost pixels. The image has lost pixels. First, there was We can see here a positive number. I'll show you. Here you can see um, scrub. So it has grown. The pixels have grown. The image difference. You can see the image difference is positive, so the pixels have grown. This shows that the image pixels have increased, and if you see here, evergreen forest, it is a negative, and the mixed forest is also in negative numbers. So we can see this means that it has lost pixels after the hurricane has hit. It has effect on the land and the forest. It has lost pixels. This basically shows that the positive number shows that it has grown pixels, and the negative number shows that it has lost pixels as this image difference. It's basically the image difference. It has lost pixels after the post Katrina hurricane. It has lost pixels. We also saw in the image that difference between. So yes, after hurricane it affects the land. So that's why it has lost pixels. For example, it has affect the bare land 5,509. It has lost 5,599 pixels. Yes, we can see from the statistics. This basically statistics table, change detection statistics table, which shows the changes in image statistics. And you can see the water has grown, increased pixels intensity has green, increased here. And you can switch between the percent if you want to see the percentage, area, area difference. This is basically we are showing the difference and computing the difference here, right? So this was the two major this was our two major functions that we can perform in change detection. Firstly, in our basic tools, the compute difference map and the change detection statistics. So this was pretty much it. Mm, see here, reference image. Now we have learned two things. The firstly, how to compute a change detection map and how to plot them and open and compare the images, by loading the bands. And secondly, we have learned how to plot a change detection statistics, how to build a change detection statistics table of the initial and the post final state and compare the changes in the pixels. Yeah. You can see the changes in the difference as I explained you before and after the hurricane, the changes on the land, the image of the land. There is much difference. So this is all from my side. So I'll see you next in the next tutorial. Thank you.